share.
Okay. So main topic.
All right, Math 0099. We're starting with reminders and startup responsibilities today. Quiz 2 is now open. It's your attendance single question. It says, I attended class this week. Make sure you get that taken care of because that is, attendance is graded as a chapter test at the end of the semester. I ask that you email me your U.S. postal mailing address. Please do that so I can get your little cheat sheet crib card mailed to your attention. And today I'm going to be looking at GeoGebra, so you will want to download GeoGebra to your device. GeoGebra, kind of an odd name perhaps, it's geography or geometry and algebra, our graphing utility. It is free, and your site is www.geogebra.org/download. Scroll down on that page until you see GeoGebra Classic 5. And that's what you want to download for this class and others in your math career. It is free, and you will need to purchase a graphing calculator for this class. All right, we're finishing up and a little bit of review yet today, particularly with our exponents. 4 squared times t. Well, 4 squared is 16 times t, I guess. 4t squared. That's 4 times t squared. I don't see that I can simplify that at all. The opposite of 4t squared. That's the opposite of 4t squared. This is the same as -1 times the quantity 4t squared. A -4, the quantity squared times t. Well, this is where we want to make sure we know what our base is. We have a clue with our parentheses. Our base is -4. So we have a negative base times itself twice. And a -4 times a -4 would be a positive 16. 16 times t. The opposite of 4t, the quantity squared. The opposite of the quantity, 4t squared. Well, we have a clue again. Our base is 4t times itself how many times? So that's 16t squared, I guess. But now I need its opposite. -2 cubed. Again, I'm protecting the sign. I have a negative base. I have a clue. I have a negative base. So that's -2 times -2 times -2. And we know that when we have an odd number of negative bases, our answer is going to be negative. So I know the sign. And 2 times 2 is 4 times 2 would be 8 for a -8. The opposite of 2 cubed. Well, I have a clue. It's a 2 is my base, a clue. I have a positive base. 2 times 2 times 2 is 8. But I need its opposite.
So what's the difference between if it's inside and outside?
It indicates whether you have a even or a negative or a positive base. This is your base, -2. -2 times itself 3 times. This is, oh, I have a positive base. 2 times 2 times 2 is +8. And I need its opposite. So it's very important that you know whether you have an even or an odd base,
Both of them
because
are,
it makes a difference on the sign of your result.
both of them are negative.
Well, yes,
So
they're two different problems. This is -2 times itself, -2, -2, 3 times. This is a -2 times a -2 is a +4 times a -2 gives you that -8, right? This is, oh, I got the opposite of a positive base times itself 3 times, so that's +8, but I need its opposite. -4t, the quantity's cubed. So I have a clue. I have a negative base, right? It's -4t times itself how many times?
3.
And a negative times a negative is going to be positive. 16t squared times a -4t. 4 times 16 is 64. For a -64, and t squared times t is t cubed. So I have a -64t cubed. Okay. And the opposite of a 4t, the quantity cubed. Well, I have a clue. I have 4t as my base. So that's 4t times itself 3 times. 16, 64, and t times t times t is t cubed. 64t cubed, but I need its opposite. So just care in taking care of your positive and negative bases with exponents. On page 268, we have our final recap of definitions and rules for exponents. So a good page for you to review a bit is page 268. And reminders that an exponent of 1, any base raised to the first power is the base itself. An exponent is 0. Any base raised to the 0 power is 1 by definition, except a cannot be equal to 0. 0 to the 0 power. Negative exponents. Any base raised to a negative exponent, we take the base to the denominator and change the sign of the exponent. So if I have 1 over a to the negative n, I'm going to take the base to the numerator and change the sign of the exponent. The product rule. I have same bases in multiplication, I add exponents. Quotient rule. The same base in the numerator and the denominator. My exponent rule is keep the base and subtract from the numerator's exponent the denominator's exponent. Of course, our base in the denominator could not be equal to 0. Division by 0 is undefined. The power rule. I have a base raised to a quantity, So I have a to the m raised to the n. A base raised to a power, the quantity raised to a power. And I multiply exponents. Keep the base, but multiply exponents. Raising a product to a power. I have something times something as my base. A times b is my base. I have a clue. AB raised to the nth. I multiply base exponents. So a to the first power times n would be a to the n. Multiply base exponents. I have b to the first times n would be b to the n. And raising a quotient to a power, I have a over b, the quantity raised to a power. So I have something divided by something raised to a power. Of course, your denominator cannot be equal to 0. And you multiply the numerator's exponent by n, you multiply the denominator's exponent by n. Remembering, division by 0 is undefined. So starting on page 274, which is section 4.3. And we're starting out with definitions of new terms. We have a monomial. A monomial is an expression of the type a times x to the nth, where a is a real number constant, and x is your variable, and n is a non-negative integer. So we have the form a to the x to the n, where a is any real number constant, x is your variable, and n is a non-negative integer. Definition on page 274. So non-negative means that our integer cannot be negative. So some examples are 3/4 y to the 5th. Okay, I have any real number as a constant times a variable raised to the non-negative integer. So that's valid. -2. -2, well, that's any real number, right? My variable is x to the 0 power. X to the 0 power is 1 by definition, so -2 times x to the 0 power is -2. 5y plus 3. Well, this is a monomial, and this is a monomial. We've learned a constant is a monomial, but now it looks like I'm using my monomials in operations like addition. So then we introduce our polynomials. Polynomials. Well, mono means one, so this was one term of the form pattern, ax to the n. A poly means many, so a polynomial is a monomial or a combination of sums and or differences of monomials. So a polynomial it could be a monomial. So when you see directions that say solve this polynomial, it could actually be a monomial. A monomial is a subset of a polynomial. A polynomial is a monomial or a combination of sums and or differences of monomials. So our example, 5y plus 3 would be a valid polynomial. I have a monomial plus a monomial. Be careful, polynomials use what operations? Sums and or differences, which means adding or subtraction. So we have one example there, 2 minus x cubed. That's a monomial, and I'm subtracting a monomial. -5x cubed plus 7x plus 10. That's a valid monomial. This is a valid monomial. This is a valid monomial. And I'm adding these monomials as a polynomial. Invalid examples. x plus 3 over x minus 4. Well, x plus 3 is a valid monomial or polynomial. X minus 4 is a valid monomial. Why would that be invalid? This is a quotient. It's a quotient of monomials. It's not sums and or differences of monomials. That's invalid. Five x cubed minus 2x squared plus 1 over x. I'm adding and subtracting monomial, monomial. What's the problem here? Well, 1 over x is equal to x to the negative 1. And our definition of monomial says a monomial is an expression of the type a to the times x to the n, where a is any real number, constant, and n is a non-negative integer. So we got, oops, so that is invalid as a polynomial. And 1 over x cubed minus 2. Again, this is a quotient. It's not the sum and or differences of polynomials. It's something else. We're dividing monomials here. Well, then we're asked to evaluate polynomials when x equals a negative 4. So I'm carefully going to write down my expression. And for every occurrence of x, I'm substituting a negative 4. So I have 2 subtract. Here's my x variable, and I'm going to substitute carefully, protecting the sign, and copy everything else down the same. So that's 2, change subtraction to addition, add the opposite. Oh, we have exponents. So a negative 4 cubed we know is we're solving, we have a negative base times itself 3 times. We know it's negative. 4 times 4 is 16, times 4 is? Okay. Any problem with that? It's a negative base times itself an odd number of times. We know the answer will be negative. Okay. So now I have 2 plus the opposite of negative 64. I have a negative 64, I need its opposite, which is, my answer is 66. So again, careful substitution, maintaining the sign of your base. And the opposite of x squared minus 3x plus 1. And we're supposed to evaluate when x equals a negative 4. So I'm carefully going to copy everything down the same. And for every occurrence of x, I'm going to substitute a negative 4. Copying everything down the same, I have the opposite of, there's my x variable. I'm substituting a negative value. I'm going to protect the sign, square it, minus 3. Here's an x variable. I'm carefully going to protect the sign and copy everything else down the same. I have exponents. I have a negative base times itself an even number of times. A negative 4 times a negative 4 is positive 16, but I need its opposite.
Negative.
I have negative 16, change subtraction to addition and add the opposite. I have negative 3 times a negative 4
Negative 12.
would be positive 12
Why?
plus 1. Negative times a negative is positive. 3 times 4 is 12. And now we get, I'm adding negative 16 plus 12 would be negative 14
Oh,
plus 1. Negative 14 plus 1 is a negative 13? Is that right? Oh, no. That's going to be a negative 4, right? Negative 16 plus 12 is a negative 4 plus 1. And a negative 4 plus 1 is a negative 3. There you go. All right, then on page 275, we're asked to graph to double check our answers. So our graphing connection. And in chapter 3, you were graphing linear equations, so I'm assuming you have some acquaintance with GeoGebra and probably have already downloaded that for homework assignments in Math 98. But we'll introduce GeoGebra. Again, GeoGebra is our free graphing utility. You'll want to download that according to the directions that I gave you in the overview document. Kind of setting this up for demonstration now today. So we have our main menu along horizontal top. When you start a new graph, you're at the selector tool button is active. Our input box is at the bottom where we'll type in our equations to graph. I'm going to use the last button on the button bar. It says to move. I now have the hand, which means you can pan. Click and grab your graphic area, move it around. If I right click, I'll be able to turn on or turn off the grid. It acts like it kind of dead, huh? Okay. Turn on or turn off the grid.
ooh, that's cool.
Yeah, I like it about better, but for some options it might be helpful. Okay, so in the input bar, I'm going to enter y equals 2 times x minus 2. 2x minus 2. We know that's linear from chapter 3. We're looking for when x is 3. So solving graphically when x is 3. When x is 3, it's right there. Looks like it's up in this area, right somewhere. When x is 3, y is
4.
for sure.
That was a guarantee.
Kind of looks like it. That's a problem with graphing. I mean, it's not always real accurate, but we can check, can't we? I mean, you're pretty sure it looks like it's 4, not 4.0001 or something like that. So let's try our vertical line. X equals 4. When x intersects with our graphed object, oh, it's not 4. When x equals 3, wasn't it?
Yeah.
When x equals 3, we think y equals 4. Maybe pretty close.
Right.
Okay, so we have an intersection, right? So graphically, we could check our intersecting point to verify our supposition. We want to intersect. I'm just going to click on the line that I want to intersect in my vertical line test. And there's that point A. And in my algebra window, my left-hand navigational window, sure enough, point A has been established and labeled. This is where it gets kind of. I have my line y equals 2x minus 2 and my test line when x is 3, and then that intersecting point's labeled for us when x is 3, y indeed is equal to 4. And if it were 4.5, that would have been acknowledged and labeled as point A as the intersection point. So we can solve these polynomials by substituting the value they give you and looking for that intersection point using GeoGebra. So in GeoGebra, we have our selector tool, allows us to select something like point A and drag it to a location that's a little more visible. G is labeling our x equals 3 vertical line, and F is labeled as the line that we were plotting. Our grid, you can certainly make use of that again, turn it on, turn it off with a right click. Your move tool is the last button on the button bar, and I try to get my origin at a comfortable location in the working window. We're not going to save this, so let's just do File New.
There's a website.
I'm on downloaded web version. There is an app version. Make sure it's Classic 5. Okay, we're supposed to evaluate. The polynomial n equals x squared minus x when x equals 10. So careful substitution, you got the answer.
No.
Your number is equal to
100. 90. That's an easy one. All of them gonna be right?
yeah. Okay, so that one I can throw away. How about this one? We're supposed to evaluate the polynomial from our story problem on page 276. So we're dealing with a medical dosage. The concentration C in parts per million of a certain antibiotic in the bloodstream after T hours is given by the polynomial equation. So you take your antibiotic and after the first hour, maybe you're feeling, better, probably not. After maybe the third, fourth hour, you might be feeling a little bit better, but it's in your bloodstream and you're confident it's going to work. And then at bedtime tonight, you're thinking, I'm not feeling just the best. And obviously, the concentration in your bloodstream has worn off. So it's probably time to re-administer your antibiotic. So we want to determine, after T hours, what's the concentration in our system. So find the concentration after 2 hours. So our polynomial then is given to us as concentration equals a negative 0.05 t squared, where t is time in hours, plus 2t plus 2.
How'd you get 0.05? What's that?
They gave that to you. They gave you the concentration polynomial. That's in your ebook story problem. We didn't have to design the model. They gave it to us. So that's given. So t, we're supposed to solve when t equals 2 hours. So we're substituting. For every occurrence of t, I'm going to substitute 2, but copy everything down the same. Exponents. 2 times 2 is 4. Exponents are done. Multiplication from left to right. A negative 0.05 times 4 is negative. What'd you get? 0.2 plus 2 times 2 is plus 2. So I'm addition now. So from left to right, 4 plus a negative 0.2 is 3.8, right? 3.8. And then adding, our concentration is equal to 5.8 hours. So, well, 5.8, what's that unit? Parts per million. So T, we're substituting hours, and our concentration is 5.8 after 2 hours, which is 5.8 parts per million is what the unit measurement was. Okay, next we're looking at a graphical interaction again, where we're using this same formula, but we're going to solve graphically. We have time and concentration. Concentration is equal to a negative 0.05 t squared plus 2t plus 2. Now for GeoGebra, we only have x and y. So we're going to solve graphically. Y equals negative 0.05 x squared plus 2x plus 2. So back at GeoGebra, my equation to input is y equals a negative 0.05 x squared. Use your caret symbol to represent your exponents. Plus 2 times x plus 2. So we have, doesn't look like it's linear, Well, I'm going to pan around to kind of see if I can follow or see what's going on here. And this is called a parabola. As time passes, your concentration increases in your bloodstream and then types to peak off and then decrease in your bloodstream. So the curve makes sense to us for the application. But we can't really see much of the curve right now in the working window. So let's look at some of the features that allow us to fine tune your grid. So I did a right click on the grid and look at your settings, and our right window pops up for us. It's your preferences for graphing, and any of these menu buttons might pop up depending kind of on what you used the last time. We want the preferences for graphics, so make sure you get to that button within the right hand resurrected menu, because I have to change my settings for my X minimum and my Y max and min. So what we're concerned about is from 0 time to the maximum time to the 0 time again in the bloodstream. So we really aren't concerned about a negative output. So we're working with the quadrant number 1. So let's set our X minimum to 0. And our X maximum kind of looks like on your grid over and across 22 maybe. So let's pan down for our X maximum. We're looking at the 0 for X and now going over to X. Looks like 40 plus hours time on the X-axis. So let's let our X max be 45. And we're just guessing. Okay, I'm panning back. And then our Y minimum and our Y maximum. Well, our Y minimum would be 0, but our Y maximum's up there about 22. So maybe try 0 again for Y for a minimum. And let's see what happens to our window. Okay, that looks a little more doable. There's our 0 point concentration. And it looks like the maximum occurs right there at 22 for Y, and X is down here how many hours?
20.
20? Okay, let's just try that intersection clever plan again when X equals 20.
Damn.
Looks pretty good. So let's double check that point intersection from the point button on your button bar. Let's confirm you can click to intersect your object in your algebraic window, or you can click each object. So a couple ways to do that. And it says that your point A is at 2022. That doesn't mean it's a maximum. It could be 22.3. But we can solve and substitute our guess 20 and 12 back in for your X and Y to determine. Without knowing the graph, you might not have been able to guess a reasonable maximum for Y. Now at least we can say, well, when X is 20, you could determine if you'd hit a maximum or not. So several things were shown with GeoGebra for tips and hints and tool control. You can move your graph around with your panning tool. That's the last button in the button bar. You can select an item with the selector tool, the first item in the button bar. Intersecting objects, that's our point intersection second button on the button bar, and we use the intersection function. Right click to add and subtract your grid, and then right click for the graphics. It's kind of a little setting button, the gear button. And then it resurrects our right-hand navigational menu for preferences for graphing. Make sure, in this case particularly, we were setting our window size. We wanted to look when X is 0 through about 40-ish, and when Y was 0 through maybe 30, giving us that kind of picture window of what that maximum was for this curve. So we had to hone in so that our curve would fit within the dissection portion of the curve within our working window. And that's how you can set your X, Y, and minimum and maximums in your preference window. A couple other things that we can do on the second to the last button on the button bar, you can add text to your graphics. So I'm just going to click to add, and this is math 0099. You could add a page reference, problem number, and of course your name, and then make arrangements to save and submit your graphing project. So click OK. Now we have this text on our grid. I might want to select it, and now I can move it around. It's a text box, it's a text object. Right click for object properties, and then your properties for your text box resurrects, and maybe we'd like to have color and text size, styles. There's only a couple styles. Size, very large. So some ways to label your homework that you might be submitting in the future. All right, several of you didn't complete quiz 1 for attendance, so that's a 0. Remember that the quiz category counts as the test category, so you're not able to get 100% right now, but it's pretty easy to get 100% in your attendance category, and it counts as a test. So I would be paying attention to that. Your syllabus quiz, there's several of you that didn't take that. Be sure you get that done, or let me know that you're participating in your class, because I'll be evaluating that in the next couple days. That's how we determine if you're participating in class. We haven't had a test or a quiz or anything yet to speak of, so that's how I make my report to administration, which is due soon. And then the overview document at D2L. The overview document at D2L is your daily journal with me. That's where I write, what did we do in class today? And I write, you need to download GeoGebra with instructions. I indicated to you that you need to send me your U.S. postal mailing address. All of those details, along with assignments, homework, projects, and tests, and their due dates, are listed in that overview document. So if you haven't looked at that, it's something you should look at daily and check off. I got this done, I got this done, and so on. So check your overview document at D2L, and thank you very much.
So if I didn't get the quiz 1,
That's a bad deal. Were you in class last week?
yeah.
You were.
One day.
For us, you still want us to email you our addresses, or